All right, so this video we're talking about the basics of a pyramid and a cone. And the difference between a pyramid, a cone, and a prism and a cylinder, okay? Notice how in number 5 and number 6 and number 4, the base shape is either a triangle, a square, or a circle. But each of the tops of them are pointed, meaning rather than it going up to another triangle or the height raising to another square or the height raising to another circle, that all comes to a point, okay? So, but the only difference is we still find the area of the base shape, okay? So length times width for a square or rectangle, pi r squared for a circle, or half base times height for a triangle. And then we multiply that third dimension, which is height or width. Then, for a pyramid or a cone, what we do is we divide it by 3, because a cone is only a third of a cylinder, and a pyramid is only a third of a prism. Okay? And the way I remember to do that is that a pyramid is 3 syllables, so I divide by 3. Or ice cream cone is 3 words, so I divide by 3. But we're going to focus on number 5 here. And again, I recognize it's a pyramid, and the base shape is a square. And the area of a square, or just a rectangle, is going to be length times width, which it says 2 times 2. So that's going to be 4. So 4 yards squared. Okay, but now we have to find that third dimension, height. But don't be fooled. Notice how in this pyramid they gave us the slant height, which is not the same as the actual height. The actual height here I'm drawing in orange. Okay, so they have a line for it, but we don't know anything about that information. But here's what I do know. All right, so I know that the length of this side is 2 yards, it tells me. And whenever we drop down the height from the point of the pyramid down to the square, it's always perfectly in the middle. The square will always be perfectly, or the height will always be perfectly in the middle, okay, of all sides. So it basically cuts that line in half. So if we know the full red line is 2, that means the smaller red line I drew above it, this is only going to be 1 yard, okay? And if I know that that's 1 yard, that's 10 yards, and of course when it drops straight down it creates a right angle. Isn't this a right triangle that I can use Pythagorean theorem to solve that missing height? Yes, I can. So let's do it. So in this particular pyramid, it's going to be 1 squared plus the height squared, which I'll put h squared, equals 10 squared. Okay, 1 squared is 1, h squared stays h squared, 10 squared is 100. Subtract 1, h squared equals 99. All right, and then depending on what I want you to do here, I'm going to go ahead and leave it in simplest radical form. I'll do the decimal calculation at the very end, but I want to do this like this because this is what I want you to practice of. So h equals, we can break down 99 into 3 times 33, and we can break down 33 into 3 and 11. All right, those are all prime numbers. We circled the 3's because there's a pair of them, 3, okay, and the 11's all by itself, so it stays. So the height of the pyramid is 3 radical 11. Okay, so that's the missing dimension we have here. So 3 radical 11 is the height. So we found the area of the base already, so we just multiply in 3 radical 11. All right, so 4 times 3 is 12 radical 11. But remember, it is a pyramid, so that means we have to divide by 3. And when we divide by 3, we can reduce 12 over 3 to 4 over 1. So my final answer for volume is going to be 4 radical 11 yards cubed. Okay, that would be if I left it as an exact answer with radicals involved. But if you made it a decimal, what we do is we do 4 times radical 11, and I get an answer of 13.27 if I'm rounding, 13.27 yards cubed. Okay, so both of those are acceptable, but I want us to be in the practice of always using exact numbers. And I'll show you another example of what that means with the cone and using pi.